Ever pondered over the question, how did the sun come into existence? Our sun, a seemingly eternal beacon of light and warmth, is the life-giving force that sustains our planet. It's more than just a celestial body in our sky, it's an essential element in the delicate balance of life here on Earth. The sun's radiant energy fuels photosynthesis in plants, which in turn provides oxygen for us to breathe. Its heat maintains the Earth's climate, enabling life to thrive in diverse forms. From the perspective of our blue planet, the sun appears constant, unchanging, a fixture in our daily lives. But have you ever wondered, how did this colossal, fiery orb come to be? The sun's creation, like that of all stars, is a cosmic saga that spans millions of years. It's a tale of transformation, with humble beginnings in the expansive, cold void of space. The story begins with cosmic dust and gases, primarily hydrogen and helium, scattered across the universe. These particles, seemingly insignificant on their own, hold the potential to ignite and form the blazing stars that light up our night sky, including our sun. Cosmic dust and gases don't spontaneously form stars, though. It's a complex, intricate process that requires just the right conditions. The universe, in its profound wisdom, creates these conditions through a series of cosmic events, some of which are still beyond our complete understanding. Think of it like baking a cake. You start with simple ingredients: flour, sugar, eggs, but it's the process, the precise measurements, the careful mixing, and the exact baking time that transform these raw ingredients into a delicious dessert. Similarly, the creation of the sun is a cosmic recipe, with cosmic dust and gases as the primary ingredients, and the universe as the master chef. So, how did this magnificent star, the sun, get its start? Let's delve into the mysteries of the cosmos. The birth of the sun begins in a nebula, a cosmic nursery of sorts. But what exactly is a nebula? Imagine an immense cloud of gas and dust scattered across the vast expanse of space. These nebulae are the cradles of star creation, where the raw elements necessary for the formation of stars and planetary systems reside. Each nebula is a swirling mixture of hydrogen and helium, the two lightest and most abundant elements in the universe, interspersed with specks of heavier elements. These materials are the remnants of previous generations of stars, which have lived out their lives and returned their substance back to the cosmos. The nebula is not just a reservoir of matter, but also a repository of chemical complexity, a testament to the ongoing cycle of star birth and death. Now, the story of our sun begins in earnest. Within the nebula, certain regions start to become denser than others. This is not a quick process, but rather it takes place over hundreds of thousands of years. The denser areas begin to draw in more and more material, slowly growing in size and mass. This is due to the inexorable pull of gravity, the cosmic glue that holds everything together. As the material accumulates, the center of the nebula starts to collapse under its own gravitational pull. The collapse causes the core of the nebula to heat up, initiating a process known as nuclear fusion. This is the heart of a star, the engine that powers its light and heat. However, at this stage, our sun is not yet a fully fledged star. It is still a protostar, a baby star in the making. The protostar continues to grow, feeding off the surrounding nebula, until it has gathered enough material to sustain nuclear fusion on a grand scale. And thus, the stage was set for the birth of our sun, a process that took millions of years. The nebula, the cosmic nursery, had done its part. Now, it was time for the protostar to step into the limelight and become a star in its own right. As the nebula collapsed, the center started to heat up, forming what we call a protostar. Now you might ask, what's a protostar? Well, it's essentially a young star in the making. It's the heart of a new solar system. Not quite a star yet, but well on its way. The formation of a protostar is a fascinating process, one that takes place over millions of years. Picture a nebula, a vast cloud of dust and gas in space. Within this nebula, a region of dense gas begins to collapse under its own gravity. As this material falls inward, it forms a spinning disk of matter. The center of this disk, where the most material gathers, becomes incredibly hot and dense. This is the birthplace of our protostar. It's a chaotic and violent environment, but it's also the cradle of the star's creation. Now here's where things get truly mind-boggling. As the protostar continues to grow and heat up, something amazing happens deep within its core. The temperatures and pressures become so extreme that hydrogen atoms start to collide and fuse together. This process is known as nuclear fusion, and it's the power source that fuels all stars. When nuclear fusion begins, it releases a colossal amount of energy. It's like lighting a match in a room filled with gasoline vapors. The energy radiates outward, creating an intense outward pressure that balances against the inward pull of gravity. This equilibrium is what keeps the star from collapsing in on itself. So our protostar is now a nuclear reactor, fusing hydrogen into helium and releasing an incredible amount of energy in the process. But it's not a star just yet. It's still growing, still gathering material from the surrounding nebula. But it's on its way. It's on its way to becoming a star. And this, my friends, is just the beginning. This marked the beginning of the Sun's journey from a protostar to a main sequence star. The protostar continued to grow hotter and denser, leading to the birth of the Sun. Our protostar, this amorphous young object, was a seething mass of gas and dust. Over time, it continued to collapse under its own gravity, growing hotter and denser. This process, called gravitational contraction, spanned over countless millennia. The heart of the protostar started to reach a staggering temperature of millions of degrees, and the pressure within its core became immense. In this crucible of heat and pressure, something truly extraordinary happened. The hydrogen atoms, the simplest and most abundant element in the universe, began to collide with such force that they fused together to form helium atoms. This process is known as nuclear fusion. Now, nuclear fusion is not just your everyday chemical reaction, it's the process by which stars, including our Sun, generate their energy. When hydrogen atoms fuse together, a tiny fraction of their mass gets converted into a colossal amount of energy, as dictated by the famous equation of Albert Einstein, EmC2. This energy, in the form of light and heat, is what makes our Sun shine brightly in the sky. So our once humble protostar, through the power of nuclear fusion, transitioned into a fully fledged star, entering the phase known as the main sequence. A star in the main sequence phase is in a state of hydrostatic equilibrium, where the inward force of gravity is perfectly balanced by the outward pressure from the fusion reactions in its core. For our Sun, this process took around 50 million years. 50 million years of collapsing, heating, fusing and shining before it finally settled into the stable star we see today. And there you have it, the birth of our Sun, a tale of cosmic proportions, a story of gravity, heat, light and the power of nuclear fusion. Finally, after a journey spanning millions of years, our Sun was born. So, what have we learned about the birth of the Sun? We've journeyed through the cosmic nursery where the story of our Sun began, amidst the interstellar medium, a sea of gas and dust. This nebula, as it's called, was the cradle of our Sun, a silent witness to its inception and evolution. The nebula didn't stay calm for long, though. A shockwave, perhaps from a nearby supernova, sent it into a spin, causing it to collapse under its own gravity. This collapse birthed a spinning disk of material, the solar nebula with a dense hot core at the centre, our protosun. The protosun, however, was not yet a star. For that transformation it needed to reach a critical temperature to kick-start nuclear fusion, the process that powers stars. This phase was a delicate balancing act between gravity, pulling material in, and thermal pressure from the core, pushing it out. This struggle continued until the protosun matured into a fully fledged star, our Sun. The birth of the Sun marked the dawn of our solar system. The remaining dust and gas around the Sun eventually coalesced to form planets, moons, asteroids and comets, resulting in the vibrant cosmic neighborhood we call home. The Sun's creation, from a nebula to a star, was a process of transformation and evolution, spanning millions of years. Today, it continues to shine, providing the energy that drives life on Earth. Its light and warmth, which we often take for granted, are reminders of its cosmic journey and the intricate processes that led to its formation. Understanding the Sun's birth not only unravels the mystery of its creation, but also illuminates our understanding of the universe, of star formation, and of our place in the cosmos. It's a testament to the grandeur of the universe and the delicate balance that allows life to thrive. Next time, when you feel the warmth of the Sun, remember its grand journey from a mere dust cloud to the radiant star that it is today.